I will post. It's now recording. All right, let's begin. Little history of Fly to Learn, and many of you are involved with the Gamut competition. I may have some teachers here who just want to get some training, but for those involved with the Gamut competition, let me just give you a little bit of experience about what got started in Fly to Learn and how it pertains to this competition and our goals were. All right. And I'll keep this real brief. I know you're here to learn about the software, but this will give you a contents or a frame. We started Fly to Learn as a way to encourage the next generation of engineers. We thought aviation was an awfully good hook. Randy is a pilot, an accomplished pilot, several thousand hours. I am not a pilot, but I have soloed, and I've been teaching kids about flight for years and years. So I was looking for something that would allow us to do that and was more than just a flight simulator. We'll get into that in a little bit. But you're going to see it. We do have 10 lessons, and as they apply. The good folks at GAMA approached us several years ago about doing a combination. They want to encourage interest in aviation, particularly general aviation, and in engineering and STEM careers. Now, just real quick, just super fast reminder, practical application of science and engineering is definition of engineering. And some of the goals that we had started with this and with the competition, honestly, increase science and math, prepare kids for college, promote STEM careers, next generation of aviation professionals, which all results in jobs. I am not only interested in encouraging kids to go to college 4 years, as well as 2 years degrees and apprenticeships. There are lots of really great careers in aviation right now that are going unfulfilled. It's important about that next generation of aviation professionals. The average pilot in the United States last year was 56 years of age, which is incredible. So there's a real interest to get kids interested in flight, and because it plays a very big role in business and commerce in this country. And there's some excellent jobs for folks. All right, so goals of Fly to Learn. We want it engaging. We want it academically rigorous. You're going to see that we use math and science throughout the 10-lesson curriculum. It stresses both the science and engineering methods. It's aviation theme. That's only second to, I think, dinosaurs. Young kids are most interested in, but it's one of those themes in life that lots of people are interested in aviation. We had a goal. You do not need joysticks or any special equipment with this. You can fly just fine with your mouse or your mice. It runs on older computers. That's why we're in X-Plane 9. For those of you that are on DVD, you're good to go. Some of you have installed it on USB drives. It's kind of a strange workaround, but we use X-Plane 9 as opposed to, say, X-Plane 10, because we found doing surveys that most school computers couldn't run the graphics-intensive semi-modern simulations. So we went back a little bit older with this, so that way it would run on older computers, in schools. And we tried to also, by licensing old software, we could keep it real inexpensive. As a teacher, I know what it's like to try to keep things under budget. All right. The Fly to Learn program consists of 3 parts. X-Plane 9, student-teacher lessons and worksheets. We'll give those, make sure that you can find those later for you. Some presentation materials, slides, videos, and webinars. Like I said, this webinar will be posted and put on YouTube. All right. As far as X-Plane itself, it's a tremendous flight simulator. It also comes with Plane Maker. And let me explain how this works, and this is why it's important for the contents they're using in your class. And I'll give you my history when we did teaching engineering. I used to use another, they're not in business anymore, another very famous flight simulator. X-Plane works fundamentally differently. The gentleman who designed it, Austin Myers, was looking for something in college because he was taking flying lessons. He couldn't afford it. So he started writing a program. And the way he did, he was studying aeronautical engineering. So he combined that love by using what would be called finite element analysis in some ways, but they call it blade theory, where he took the wing, he cut the wing into 10 pieces because that was the optimized best. He applied the aerodynamics of that wing at any given time in a flight to tell you how, and then put the wing back together and then told you how the plane would fly. This is opposed to most simulators that use a big lookup table. They go out, they take an airplane, they put a lot of recording equipment on it, and they say, okay, at 1,200 feet, flying at this speed, how does the airplane behave? If I push in the throttle, what will the plane do? And then the software simulation goes, oh, okay, I'm flying at 1,200 feet. Someone pushes the throttle, I react this way. But it's just following a very elaborate set of directions. X-plane, on the other hand, is saying, I have a wing, let's push it through the air. How would this air would behave? And then have flying accordingly. So what that means is you can use something like PlaneMaker, and if I change the aspect ratio, the plane will fly differently. Where most simulations it wouldn't, because it would still be using the same lookup table. All right. So that's why I was really excited about it, because in the classroom, like a lot of you are in, you go out and build little model airplanes, you take the kids out, trade one variable, and you're hoping like heck the plane flies differently. And it's not, and if it is flying differently, it's because they changed the aspect ratio, not because they didn't build it as well as they would have liked to build it. Especially when kids weren't working with their hands as much as maybe past generations have. So that's why we use X-plane. And all right, there's in the curriculum itself, there's 10 lessons. You're going to look at the first 6 lessons are more science themed. It's more of how an airplane flies, the science of flight. The last 4 are more of the engineering theme. It gets to practicing all the STEM skills, and I know STEM has gotten way overused, STEM, STEAM, all that stuff. We've been doing this since 2012, so we've been, and I started teaching engineering at my school back in 1989. I've been there 28 years. Anyways, data collection, data analysis, engineering trade-offs. And you're going to see we can graph with this, so you really can collect some cool stuff. Students design an airplane in the final lesson. And that's going to get back to the competition for those who are involved in the Gamma competition. Now, what you generally do on a lesson is introduce what you're going to cover that day, maybe show a takeoff video, hand out to students the worksheets. It does have worksheets from the fill out with directions of what they're supposed to do. Have the kids read it. There's been 28 iterations of those worksheets, so we've covered about everything on there. A teacher tip, if a student says to me, what do I do next? What I will ask them, well, show me in the directions where you don't understand, where it confuses you. And almost always they would go back, read the directions, and they know, oh, this is what I do. So it encourages them to read on that. Okay. And then, of course, got a little bit of worksheets, but they get to fly the plane a lot. They get to change and design the airplanes. They get very involved there. Okay. Before we go any further, raise your hands again if you have a question. We have 17 folks here tonight. Great turnout. Do we have anybody have a question? Okay. Well, then we're going to go on. All right. So this is the table of contents. This should have come with you if you were involved in the Gamma competition. If you don't have that, we will make sure and get you one. Just let me know afterwards. I'll send it right to you. All right. Now, let's talk about the first flight. And in fact, the screen you're going to use mainly. And I'm going to bring it up here in a second. But you're going to see I'm using presentation slides because the software, like I said, is taking that airplane, cutting the wing up, putting the plane back together. Well, on your computer, it'll run fine. It won't look choppy, and it runs on a PC, Mac, all right, or a Mac. But over the internet, it can look a little choppy, so that's why I'm doing it this way. We have, and I'll show you the screen, how we get to it. Here's the actual software. All right, if you go up to Settings, Quick Flight Setup, it brings you this choice here. Okay, let's blow this choice up so we can look at it. Here's Laui, Innsbruck. We go to this airport. This is where you get to go to airports. You can start all your locations. Down the right is the airplane. Here's the time. If it's dark, go down here. Make sure they're not trying to fly at midnight. There's a tip. Just leave the weather clear and CAV okay right down there. That means precipitation storms. So that way we're not trying to fly through storms. As far as airplanes go, I encourage you in the beginning, to encourage your students just to use the Skyhawk and the planes we have. As they finish, we'll introduce more planes as the lessons proceed. Anybody have a question on this layout of the screen? I'll pop the, whoops, we don't want to do that. All right. I've got a problem here. For some reason it popped, but we'll just back it. All right, so let's go back. Pull this up. So if there's no questions there, let's go ahead and do a takeoff. All right, let me show you what you're going to want to do. Hit the P for pause. Then you want to hit the brake lights and push the throttle in. If you can't find the throttle, just push the down arrow, you'll see it. That black button is the throttle. Just like stepping on the gas of a car, you just push in the throttle. On an airplane, always, always take off full throttle. There's not half speed ever. You full blast. All right? And so that's what you want to do when you go to take off. You want to put it in there, full blast. Okay? So, and when you do that, so these are all lighted. You turn in the brakes, so you hit B for brake, you're pushing that throttle. So it'll look like this. The light will be off, the throttle will be all the way pushed in, and you're ready to unpause it right there. Now I'll show you on the software itself. Let me get my airplane up here. So let me bring this over here. I'm going to go Settings, Quick Flight Setup. I'm going to open an aircraft. I just use the same one everybody else is using. So that's the one second. All right, there we go. Okay, boom. Understood. I don't have my disk running on this because the computer I'm using right here. Okay, now I will hit pause. I'm turning off the brakes. I use my down arrow key to shift that up. My screen looks fine, so I'm going to push it in. All right. Now here's why I put this screen on. I wanted you to see it. Under the pause, there's a little X there. If I click there, there's a box. You can fly and keep your pointer inside that box. You can control the airplane. Once you go outside the box, it's not doing anything. So, and if the box goes away, click on it and it'll come back up. How many people have X-Plane accessible from their computer right now? Raise your hand if you've got X-Plane accessible from your computer right now. All right, I want you all, since you do, we have several people do, we're going to go ahead and I'm going to let you try to take off with this. I'm going to put your hands down. So we'll take a few moments here to just let you to take off. All right, so here it is. It's paused. All I'm going to do is, again, let me just go through this again with you. I'll turn this in and pull the throttle out. You'll see a little hand comes up there. I hit paused up there. That square may or may not be there. Doesn't matter for right now. I'm going to turn off the brakes. I'm pushing in the throttle. I'm going to make sure I have a square here. Then I hit unpause. And I keep my pointer right in line of this wing. It will pull to the left, and real airplane does. All right. So now I'm going. It might look choppy on your computer right now, but you're just going to go there. I'm going to pause it. You can see my airspeeds at 60 or 70. Then pull, just like in a joystick. I'm pulling the joystick down. That's pulling the nose. That's going to cause the airplane to rise. So I pull my pointer down. The nose goes up, and I'm taking off. I press the A key. You can just see I'm just barely off the ground. See? I'm off the ground. Let me give everybody a chance who's got it to go ahead and try it real quick. And for those people that are joining us a little bit later, we are recording this. I will put okay, something's going on. Let me go ahead and reshoot this so you can see it. I'm glad. I just saw all the questions. Thank you, folks. Let me go try something here. It's doing that start thing. All right, let's try it. Can you see it now? Great. Okay. All right, everybody can see it. Okay, that's great. Well then, let's go ahead. Just real quickly, let me go back and show you that. Then not a problem. Luckily we haven't gotten that far. Okay. Go ahead, turn off the brakes, pushing the throttle. If I'm in the front of the cockpit, I hit the key. All right. So if I click on that brake, I push in the throttle, and I keep this square here. So it will look like this. So the light will be off there. The throttle is in. And I go ahead and take off. Let me go ahead and bring the software up so you can see it. Whoops. Let me go ahead and all right, let me go back here. I'll do it again for you guys. I'm going to go into settings, quick flight setup. That's where I can do my airport. That's where the plane is. Set at 12 o'clock. Should be all set to go there. And you just want it during the day. That's the only reason why the time is there. It's in military time. So I go back. Well, let's do this. Whoops. Again, quick flight setup. So I'm going to go to takeoff runway 8. There I'm on the runway. I pause it. See the square window there? When I click my mouse, it can either go on or off that. There it is. There it is. So if the window goes away, just click your mouse again. Turn off my brakes. Use my down arrow key to. Sometimes this might be up a little bit higher on your screen. Just use the down arrow key. Push in the throttle. All right. I'm going to P for pause. Unpause it. Again, it might look a little choppy on your screen. Just holding it, gets about 70 knots, and pull the arrow down, and I climb. If you want to go outside the cockpit, hit the letter A. W's forward, A. This is all in the first lesson. Now let me look at some questions here. All right, got it. I can't see the throttle. I'm not able to see what he's doing. I can only see the tap, half a pound, not where the throttle's. Okay, use your down arrow key, Roger. You should see the whole thing then. I will go back over here. All right, let me just, if I use my, let me look outside the aircraft. So if I hit the letter W, I'm back in the aircraft. I can use the W key. Let me pull this up so you can see it. Hopefully you can see it now. Does that help? Well, I can't tell if it was my software, my webinar software that. I got it. Good. Thanks. Great. So that's the kind of stuff drives you crazy in a classroom. Hey, can I get a show of hands? How many people here are teachers? And let's do teachers so I know how many teachers and how many students. Then I guess the other people are students. So let's see. All right. A sense of how many people. All right. I'm going to put the hands down. How many people are students? Raise your hand if you're a student. Okay. Primarily teachers, but some students. Welcome students. Welcome teachers. All right. So here's the airplane. Again, if you're looking at your airplane, you don't see the whole screen, just use the up and down arrow key right there. And you control it with this square. Taking your cursor way out to the left here doesn't do you a bit of good. Out here, it doesn't do you any good. It's got to stay within the square. All right? Now, okay, so my screen's closing up half of it, which is a bit frustrating. I'm going to lift it up so you can see it. Does that help more? Now I still have to use my up arrow key. Okay, let me know. So let's let everybody take a minute or two, practice taking off there, and then we'll get to the next thing. Good. I can see the throttle. Just so you know, webinars this Monday and Wednesday. We'll have repeat webinars Monday and Wednesday of next week and the following week. So if you want to come back in 2 weeks, you can. Mix and match, whatever works. Send some students the next time. Share the webinars with anyone you'd like. I have a question regarding the curriculum information. I thought it refers to the course. Where are these videos? I will show you at the end on the Fly to Learn website. Yes, if you have USB. Now, the competition only has DVDs this year. Next year's competition, we're down the road. We'll most likely be going to digital download, so you don't even have to worry about it. No, copying to a DVD or USB drive will not work. It's part of the original copy protection. It won't do it to it. Sorry about that. Okay, I'm looking at more questions here. Yes, you have to have a DVD in your. You have to have a DVD in your DVD drive to get out of that. How do I order more copies? Like for a class of 15? Email me when this is over. We'll give you the information. They pay for the first 5, and then we sell the stuff. It's very reasonable. And it's by how many years in your class kind of pricing. Okay. All right. Why don't we go ahead and get on more, and I'll stay on and answer as many questions as people want on the road. But let's go ahead and come back to this. I'm going to move this over to my other screen so this way we can see it. Let's talk about lesson 1. Okay, so there we are. Now, in lesson 1, in fact, I can show you. Let me go back here. Here's first of lesson 1. That lesson 1 is doing 2 things. It's teaching you and the kids, or you and the teacher, depending if you're a student, how to use the software, where to go to where to click. And it's very specific, exactly step by step to do it. But after like first lesson, people really pick it up pretty quick. But you can also tell we were trying to teach science and engineering, because what we really get into in the theme of this lesson is potential and kinetic energy. Think of potential energy, top of the hill. Kinetic energy is your bike after it's been rolling down the hill. In an airplane, potential energy is altitude. Airspeed is kinetic energy. And what you have the kids do is fly the plane level, and then you have them, just draw out a line for the attitude indicator, altimeter, and airspeed indicator. Just mark it. And then point the nose down, do it again, point the nose down, see what it does to your airspeed. Then point the nose up, what does it do to these instruments? So if you're flying the airplane, and the way you can do this is you can start off already taken off. I will show you this right now. I'll come back here. So I can go back to, and it tells you exactly how to do this. Do quick flight setup, go final approach, X. So here I am in the airplane. And so what I can do is if I go down, I point the nose down, watch what my airspeed starts to get. It probably might look choppy on the internet, but my airspeed is gaining. But I'm losing altitude. And by this point in part of the lessons, what are the different instruments? This is your airspeed. This is your artificial horizon indicator. More brown means you're going to the ground. Blue is sky. This is your altitude. Shorthand is in thousands of feet. Longhand is in hundreds of feet. Okay? So watch what happens now. So I've got all this airspeed, but suddenly I realize, hey, I'm going to the ground. Not crazy about that. So I'm going to pause, and I'm going to climb up high. Hopefully not going to loop. Watch what starts to happen. I'm now up higher. I'm pointing at blue sky. I'm up higher. I'm closing in on 3,000 feet, but my airspeed is down low. So what I learned through the course of that lesson I learned in this lesson that there's this trade-off between airspeed and altitude. I can get potential energy. I can turn into kinetic energy. I can turn kinetic energy back into potential energy. But I can't create it, and I can't destroy it. So you're teaching some good basic science there. We also get into questions in here, why it's dangerous to be low and slow in an airplane. The only time I want to be low and slow is when I'm landing it. I don't want to be low and slow when there's a problem. And it's great to have a 7th grader turn and explain to you why that's the case. All right? Now, let's go on to the next one. Lesson 2, because what I'm trying to do is get through the science lessons today, and then we'll go in the engineering lessons Wednesday. That'll help you, help you to learn the engineering side of this and help you for the competition. So, in this one, it's made a force be with you. You got force, weight, introductions, and things. Again, this time, hey, click on this, click on these areas. It's very specific on what you're going to click on. So if the kids will read it, and I really encourage teachers, ask the kids to point out to you on the questions where they don't understand it. And you'll find they end up reading it most of the time. Another teacher I teach with will ask them to ask another student to show them, but I have usually, they start following, they do pretty well. Now, let's talk about how we do this, though. All right, if you go in your airplane, and let me go in the menu. If you go, click on aircraft, and you do weight and fuel, you'll find this. So let me bring the window over so you can see it. So if I go under aircraft, weight and fuel, I can change the weight and fuel of the airplane. And in this, you can change this weight. We're going to have them change it to 300 pounds and 600 pounds and 900 pounds. Now, in reality, you would never change the payload weight by 900 pounds in this aircraft. You would crash the airplane. But it's a simulator, so if it crashes, it's not the end of the world. We also change the data. We can measure things. That's what's so powerful about this software. Speeds, distance traveled, landing gear forces. You're both graphical and cockpit. All right? Does that make sense? So let me show you how we get there. And you're going to see why we do this in a minute. I'm going to go bring the real software back so you can see it. If I go under Settings, and I do Data Input Output, I can set these things. So in this case, I've got speeds, distance traveled, and landing gear vertical forces. And well, why do we do that, you might ask? All right, make sure everybody can get to this. If you've got the program, remember, go under, let me bring it back over for you. And remember, the menu doesn't always go under Settings. And if the menu isn't up, move your cursor, it'll pop up. Like there it's gone, but it'll pop up. Settings, Data Input Output, speeds, distance traveled, landing gear forces. But you can measure any of these things. 131 things you can measure. You don't really need these two checked off, but you do need graphical and cockpit display. Because let me show you what we've got. When you're flying this airplane, that information is a snapshot right there. There's my landing gear forces, which because it's off the ground, there's no load on the landing gear. The landing gear are just are hanging out there. They're not. There's the weight of the airplane is not going through the landing gear into the ground, and the ground pushing back. That's how you get those vertical forces. Up in the air, it's got nothing to touch. So not surprisingly, it's 0, 0. Here's the true airspeed. True airspeed is there's indicated because the instruments on the airplane and true. Just use true. Doesn't matter what units you are. Just be consistent. If you're using indicated, go ahead. Just be consistent. Use V true or V indicate. All right. I think you're better off V true. And there's distances traveled. All right. Don't worry about these other numbers. We're going to graph that in a minute. So I'm going to go back to data input output. Once I started flying, look at this. I'm going to bring this graph. Now, it was sitting on the runway for a while. Well, we took off in the air. So let me take off from the ground here real quick. While we do that, let's go to quick flight setup again. We're going to go to runway. We're just going to do final approach. Let's do takeoff, no final approach. Here it is. I'm going to take off here real quick. Pause it. Brake off. Push my throttle in. Back up. I am collecting this data. I've set this to collect, so I am collecting data right now. We default that it's collecting some of the same pieces of data. You can have your students collect whatever you'd like. So here we go. I just want you to see how this graphs and why this is a powerful, you can do real science experiments with this, all right? And real engineering analysis. I'm taking off quickly just to show you what's happening. All right, let's look outside the airplane. And let me make sure I took off. Okay, I'm gonna go, so right now, notice some of the landing gear is on the ground still, and some of it's the nose has come off. This left gear's come off, but not all of it. So let's keep flying it. I'm gonna unpause. Now I'd be willing to bet I'm off the ground. And now we'll look. There I am. All right, let's go ahead. Look at my graph this time. A lot of curly lines, and these two lines in particular kind of squirry. So let's do this. We'll get rid of some of these checks, and I'll show you all again to do this. So don't worry about it if you're like, oh my gosh. Go all the way down to, and it says it right in the handouts. V true, miles per hour, leave that. Turn all this off. So notice I'm getting rid of most of these lines. Keep distance. You can do it in whatever you want. I'm keeping that in feet, so I'll keep the orange. And I've got my landing gear here. Now look what this does. See the landing gear? The landing gear down here, it's not real clear. It doesn't matter what the numbers, but you'll see the red gear is 0, 0. The yellow, where it says yellow gear, is 118, and then the green gear is 313. So remember the nose gear was up. As I move across, you see the landing gear, the loads on the landing gear go down lower, 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 and at this point, they're all 0. The airplane is off the ground at that point. So then we just take our pointer up and we go, wow, it was going 83 miles per hour. 83.99, and a distance of 1361 feet. Now, that was a lot to throw at you real quick there. So let me see if you have any questions. I just scrolled over, so it did that to us. Go ahead and write a question if you got one. Any questions there, folks? Again, this is a great way to analyze your data. And in our handouts, we have the kids take off 3 times with 300 pounds, 600-pound loads, and then 900 pounds, and they graph it. And they look at the difference of what that load does to the airplane's takeoff distance. And by the way, we teach the kids the difference between weight and mass. Mass times gravity gives you weight. Okay? All right. Someone asked, can we get a certificate, something showing we completed this training? You know, I haven't done that in the past, but we certainly could do that. You come to both webinars. Yep. Oh, great question. Someone said, do you have the kids try to get up as quickly as possible or try to be consistent? I try to be consistent. And the way I try to get them to fly consistently, as I have them hold it, let me change cockpit view. You know where that X is? I try to hold it. I'm going to unpause it here so you can see it. I have them where they always take off with this always pointed right underneath that cross there. I try to keep it as close as I can. Then you can talk to them about how hard it is to be a test pilot, that he or she has to be able to fly consistently. Exactly the same way. There you go. This way you get a standard. And what you're going to find out is there are times when the plane barely takes off. You put 900 pounds in this airplane, it'll take off, but it's going to be close towards the end of the runway. Later, we're going to change the aspect ratio. That's the ratio between the wingspan divided by the width of the wing. And the low aspect ratio airplane takes off literally at the end of the runway. So we're going to look for trends. Any other question? I'll just show you one more time. Here we go. We did that with data input output. We set it. You don't really need these two up here, the disk file. The graphic and cockpit, this is what shows up in your cockpit. This graphs it for you. So you can see it here. And because I've done this halfway through a plane flight, I think I've messed, it's not collected anything. Because I unchecked it. All right. So settings, data input, data C. All right. And this is a snapshot of it. All right, let's move this out of the way. If you see a number 9999 at the bottom of that, like I just showed you a second, just so you're not wondering what the heck, that means it's not collected any data, it hasn't started recording. It's kind of, you're always learning something interesting. I think when I unclicked those 2 buttons, it cleared everything off. It's a little bit of a bug in it. It's a shame. All right, now, can we use X-Plane 10? No, you may not. Sorry, can't. Not for the contest. And the lesson plans are all really aimed at with X-Plane 9 right now. We are coming out with X-Plane 10 within the year. And we'll have the whole curriculum written for that. And then well as a little more like, for example, we're going to be looking at not only this curriculum, but how to design a runway. Okay. All right. Okay, let's go on to the next and pull this over. We just did that. Sorry. So here's our airplane. If you're not collecting any data, there's no mark in the screen. Here it is when we're collecting data. So when you're saying in the cockpit, you got cockpit unchecked under data collection. You don't see anything. Cockpit chat, it does. And you can change it. This is all the different parameters. I've hit the W key so I can see outside my airplane. And again, as I was showing you earlier, this has all the lines, though you can uncheck them, like in this case right down here. But with all the lines checked, this is still the landing gear here. That's a lot of information, so I uncheck these. So see, they're all unchecked, except for true distance traveled. Where this, right at this point here, where all the landing gear goes to 0, that we can look at V true and distance traveled. So in that second lesson, we say, well, what's the true airspeed and the takeoff distance when it's a 298 load, then 600. And it's hard to get right at 600, so it might be at 601. 298 is the default value. That's why we use that. And then 900. And then you're taking an average of each of these. And then you plot a graph. Okay. That, by the way, explains why airports have to be bigger with bigger airplanes, as a general rule. All right. Any other questions so far? Okay. Lift. Now we get into why an airplane flies. It's a combination of both angle of attack and airspeed. We build that in, so angles that tilt in the wing up. If you're saying, well, how come when I can fly level on an airplane? We build an angle of incidence. The wing actually has built-in angle of attack. There's 2 reasons for this that are commonly used to explain it. Bernoulli's principle and Newton's third law. Bernoulli's principle is a gas or liquid is increased airspeed, you lower the pressure. Bernoulli's law is basically for every action, there's an equal opposite reaction. So in the first case, there's an idea that, hey, the air's got to travel a greater distance at the same time as the air below this. Therefore, this air must be traveling faster. That creates low pressure. The wing goes up. In this scenario, we're saying, hey, there's air hitting the bottom of this, coming out that way, results with lift going the opposite direction. Think of a kite as a good example. You can go to any airport and hangar and you're going to have pilots argue which one's true. It's probably a combination of both. Now, what we are less interested in what's causing that low pressure, but we know it's there and we're interested in lift. So what we do in this plane, and watch this, come back with the airplane. I'm going to go back to my quick flight setup, final approach again. And what I'm going to do is watch this airplane. I'm going to pause it. I'm going to hit the slash. That's right underneath your question mark on your keyboard. And let's look outside. I hit the A key. W and A, practice that. A shows us. And by putting that slash there, that's the second time I hit slash, third time, fourth time it goes back. So it's normally like this. Hit it once, you get these vectors. Use the arrow key to move around it. Those are the left vectors. The red is the induced drag. That's the drag you always get when you get lift. Notice there's a little bit of drag, but not induced lift. And the yellow is what's called lift from the horizontal axis, which you really don't have to worry about for this level. Okay. Now watch this airplane. When I go to fly this, I'm going to climb. I've got a great angle of attack, but I got low airspeed. So look what my lift's doing. Now, if I point the nose straight down, I get more lift, but it's only when I add an angle of attack, I get a lot of lift. So that really demonstrates that lift is a function of both things. This also explains to kids why you can be going fast, but if you've got a really high angle of attack, you're going to lose airspeed, because we learned earlier that as you gain altitude, you lose kinetic energy, and you can stall because your airspeed gets too low. And if you get going fast, you still have to have an angle of attack. Any questions on that? One of the things I do in the classroom is see who can get the highest, get the greatest green arrows. Yeah, hey, someone said something about the negative lift on the tail. Excellent. That's one thing we get into the airplane. In stability, we get into this a little bit more. You get into a lot. Most people think an airplane balances around the center of gravity. That's the point at which the weight of the airplane, if you could hold it up theoretically with your finger, it would balance. That's not actually true. That's not quite understand correctly. This balances along the center of lift. So there's two moment arms here. Remember, that's a force and a distance. Go back in your old high school physics. So there's a moment arm from here to this tail, and from here to the center of gravity. This tail is helping balance this airplane. When its main function, this tail helps you control the angle of attack. It has lift going in the opposite way to help balance this airplane. It's the equivalent of putting more weight on the tail so it will balance. This airplane is nothing but a teeter-totter in that respect. And because that center of gravity is just ahead of the center of lift, it's usually just a few inches. Because remember in your physics, for this to be flying level, the load on this tail has to equal the load of the entire airplane. Well, that airplane's pretty, relatively heavy compared to the tail. So we have to really make the tail a really long moment arm compared to the moment arm on the center of gravity. I know plenty of model airplane builders, and real pilots, unfortunately, don't necessarily understand that. But this is why if you fly in a small airplane, any airplane, frankly, you have to worry about balance so much. I'm in Charlotte. The last fatal airplane crash we had of a commercial aircraft was several years ago, and it was because they were in a rush and they didn't balance the airplane properly. I don't know if it was the pilot didn't take the time, she didn't take the time to do it, or she was told it was a weight that it wasn't. That more weight was in it. If you remember Saving Private Ryan, the glider crashes because nobody happened to tell the pilot. They put a Jeep in there with a general in the Jeep. Any other questions? All right. Now let's go back over here. Oops. So that's with the lift. I'm going to move a little bit faster. Drag. Drag is, opposes your movement through the air. I think the best analogy for the kids is if they've ever been in the lake or an ocean, they run alongside the water. They can run pretty fast. All right. If they run their waist through it, all right. So you have force and drag. So as the airplane moves forward, drag impedes the movement because you're moving molecules out of the way, just like water. So if you run around a beach or a lake, and the water's up to your waist, it's a lot harder. That's a measurement of drag. There's two types of drag we get into: induced parasitic. Parasitic is put your hand out the window, run through a lake. That's parasitic drag. It's based on your shape. Induced is the drag that's caused by lift. And then when we talk about drag we talk about flaps. and you extend the flaps on an airplane, which is really kind of cool. What that does is it adds more drag and more lift, so you can land the plane at a slower speed. And so they'll practice flying with flaps. And we actually end up using a different airplane. Let me show you the airplane you use when you do it. I'll show you where the flaps are so when you go to do it. All right, so let's go to settings, quick flight setup, open aircraft, general aviation, open. So there it is, right? It's a King Air. You're going to fly that. So let's go ahead and fly on a final approach. Here it is as you're coming in. I'm going to pause it. And because you might be hard for you to see it, the flaps are this handle right here, and those are fully extended flaps. And when you pull this down, the landing gear up or down. So the landing gear, you're telling those red lights are telling the landing gear is down, and the flaps. And the kids then record when you put the flaps down, what does that do to my airspeed? As you can tell, we're getting ready to practice landing. And if you look at the plane, if you go outside the airplane, you can actually see the flaps extend if I unpause this. Let me see if I pause it. Get my white square, it's right down there. See, now you can see, not real clearly, but the flaps actually kick out, like in a real airplane. That's some of the things you hear in the noise whenever you go to land on an airliner. You hear that chung, 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 that loud noise as it comes out. And the bigger noise is probably the air brakes. And they are trying to stop all the lift on the wings whatsoever. And you don't see those come out until the airplane's nearly either on the ground or almost on the ground. Because that plane is no longer flying when they put out air brakes. Any questions on that? All right. Then let's back up here. And see, there's the plane with the flaps coming in. You can see it there. Now, one thing we break up at this point, and I'm not even going to, this is just for teachers. Oh, we got a question maybe. Let me look over here. How do you use the radio stack and GPS? I don't. Okay. How do we visualize drag? You can actually graph drag if you want it. You can look at some of the drag in the red lines, but it's so small that it's hard to see the difference. You can graph drag, but I really think you really end up doing is more graphing what the performance does to the airplane. Not really. Okay, all he did is, yeah, all we did is when we did, you're asking why when, and you can actually do this on it, and you can put the drag up, by the way. Let me bring up the airplane, so in case you want to do it. Right there, we have V-True and everything on the airplane. If I go to settings, data input, output, and I change my data set, I can tell it I want drag as well as lift. So here's wing lift, here's wing drag, and so you can do that. So let's get rid of distance traveled, landing gear, because I know I'm up in the air when I'm doing this. I might keep my airspeed up. There's my wing lift and my wing drag. Now, if I want, I can freeze this flat, and I can change those things. Now, you got to fly level because you're going to impact your left. So you could use that as well. Yes, it is absolutely going to be archived, and yes, I will put it on YouTube, and I will share it with everybody who signed up and everywhere else. Also, in case you got in here late and you didn't hear, we're going to have another set of webinars Monday and Wednesday of next week. You're welcome to come to that, as well as another week in March. So it'll be 3 weeks of webinars. Fair enough? Okay, great. Now let me pull this back over here. There's our twin engine. Now, sometimes you've been playing on computers. I like to break it up, and you don't have to do this, it's totally optional, but I break it up by these cheap airplanes. And then I talk to them about, let's put it together, just fly it like that. Those will fly 2 seconds, 3 seconds. Then we do things to improve it. We're going to replace this with a better rubber band. We get rid of all the unnecessary weight. I actually asked the kids, what can we do to make this plane fly better? Think about the 4 forces. And what you see is they start talking, well, let's get rid of all the weight. Let's get a bigger rubber band, which we get big rubber motor. You can buy it by the pound. And what we talk to the kids about is adding something dihedral to make the airplane more stable as we add this. Doing that, you can get 5-10 second flights. All right. And that is a great way to break it up if you want to go outside and fly some airplanes or go into a gym. All right. Well, the repeats are, no, just the same. They'll be the same webinars for people to get started. We can get through the 10 lessons over 2 webinars. But you're welcome to come and ask a question in the middle of the webinar and say, hey, I was doing this in class and we had this issue. So please, I'll give plenty of people free time to do this. I'm trying to be very sensitive to all the teachers' times here. All right. Now, and we're not even about at this point, we're at 8:30. So let me just show you a couple other things here. All right. I would say flight controls are the most involved a little bit, and we can look at an actual lesson on it. But what I wanted you to get out of that is you're talking about pitch, roll, and yaw. I think we'll go ahead and pick up with that on the next lesson or the next webinar when we start up here, lesson 6. We'll go on to that. But I do want you to see something else before we go. I wanted you to catch this tonight too, so you get a sense of this. In Plane Maker, we can take an airplane. So stability, we'll pick that up next week, or excuse me, Wednesday. I do want to show you Plane Maker so you can see where we're going with all this. Because right now, everything I've showed you, I will share with you in just a little bit where the videos are. Okay, just let me show you a little bit about Plane Maker so you can do it. All right. So there's a program right where your X-Plane file is. It's called Plane Maker. So let me go ahead. I'm going to jump out here, see if I can get out of it. Let me jump out here. So if I look it up, all right, I'm going to just pull up Plane Maker. Here it is. If I go into, and if I hit the space bar, it pulls up. If I change this wing, and I can then fly it in X-Plane, and the plane will fly differently. And we'll do that. We're really just going to focus on changing the wing. So if I make this wing like this, and then update the wing tips, and I have all the menus to help you do that. So I have the wing tips, the plane will fly differently. All right, so that's what we're going to get into Wednesday. There's the airplane. When we go right into X-Plane and fly that airplane. I don't want to say that. Okay. And the other thing we'll show you is just the aviation challenge. Now it'll be different. I'm not going to give you the actual details for the contest, but here's the shows the aviation challenge. You take off and you fly and land. In the case that comes with the software, you take off and you land on a grass airstrip. It'll even tell you which way you're going. It's a combination, the score, you get a score at the end, and that score is a combination of what you carried divided by the time it took you and the amount of fuel you used. All right? So those are the features we'll cover up with Wednesday's next video. I will also show you, let's go here. I'll bring it up in Chrome here. Let's go up here. I'm going to go ahead and bring it up right now. In my lifetime, please. Okay, let me bring it over to you in a minute. Let's try it this way. Let's use Safari. Yes. All right. Okay, so I'm going to bring up the website you want to go to. You want to go to flytolearn.com. All right. So you're going to be on flytolearn.com. You're going to go under educators. And then here are the lessons. You can download them all right there. Some videos. The videos are, some quick U-time videos, and then how-to videos and how to take off, how to land, etc. All right. All right. So if you go to Fly to Learn under educators, you should find it right there. If I load my DVD on a speed drive, can I use a speed drive? I don't know what a speed drive is. Where can we watch the webinar again? I will post it on YouTube, and I'll send out a message. It'll be out by first thing tomorrow morning, if that'll work for everybody, I hope. Any other questions on this? No, you can't put it on a jump drive. Also, too, if you go on there's some old webinar videos that are on Fly to Learn's opening page, but I would just say go ahead and use this. All right, and I have a PDF of tonight's lesson that you could use in your classroom. Hopefully, let me see if it'll let me. Earlier, GoToWebinar is supposed to allow you to do handouts. Let me see if I can get the handout on this. No, you know what? That's interesting. It's for some reason, it doesn't want to let me do a handout right now. I will mail out a link on a Google Drive to these handouts. Or if the PDF isn't too big, we'll go ahead and I'll just email it to everybody that was here tonight. Okay? All right. If we don't have any more questions, folks, do we have some more questions? Okay, you're welcome. Is there a button combination used to hide the data in upper hand? No, Don. Let me show you how we did that. If you go up to settings, data input output, right up here is where I add the buttons to hide or not hide. If I unclick the cockpit display, it goes away. Does that make sense? All right. If nobody has any more questions, let's call it a night for now, because it's already about, I guess, 8:35, 8:40 my time. I know we all probably teach the next morning. And for students, we've got a homework to do. But feel free. I'm tom.flytolearn@gmail.com. Just email me directly there. I will post everything up. You'll have it by first thing tomorrow morning for you to have. All right, folks? All right, then I'm going to go ahead and call it a night. Good night, everyone.